So I'm warning you right from the jump that this could be a really long video if I don't talk fast through it. But I encourage you to keep an eye on it, know where it's stored, because it's going to be a really valuable summary of kind of 2 to 3 weeks worth of work. So here it goes. This video is to try to finalize our plan for factoring. So before we get started and we get into all these details, 2 big ideas I don't ever want you to lose sight of. First one is you have to maintain equivalence when factoring. You know about math, you know about the way you can communicate math, whatever they give you. If you're going to change the way it looks, that's perfectly okay, as long as you do so in an equivalent manner. Either write something that has the same value or do a balanced thing to 2 sides of an equation. That's not part of today's conversation. Next, I want to encourage you that when you watch someone who is really comfortable factoring, it looks effortless. But the fact of the matter is they've just ingrained this idea that the number of terms in an expression is the lens through which they look to go, what techniques do I have available to me? So that's the way this whole thing is going to be structured. So when we go into factoring, I give you an expression, the directions are factor, or you realize because you've gone further in math that factoring would be convenient for us right now. When you go to factor, always look for the greatest common factor first. It's not very often you're going to hear me say always in a math class, but yes, if you're factoring, always look to take a GCF out first. Only good things can happen if you do it. Next, when you're looking at a polynomial and you know you need to factor, or you've been asked to factor, think about it as if the polynomial has this many terms, then my option or options for factoring is or are. And that's the way you want to organize your thinking. And that's the way we'll organize this. We'll start with 2 terms. If a polynomial has 2 terms, my option or options for factoring here in Algebra 1, it's a real short list, it's one thing. After you've taken a look for a GCF, if you're looking at 2-term expressions, the only thing that you could look for is difference of squares. So once you notice that it's a difference of squares, or if you notice a difference of squares, then you can think this is a formulaic thing. I'm looking at a binomial. I'm looking at 2 terms. The first one's a perfect square. The second one's a perfect square. There's a minus sign in the middle. I've identified it as a difference of squares. Well, then that means that my factored form is going to look like this. 2 sets of parentheses, big enough each for 2 terms. I'll split the a squared nicely, thinking square roots maybe. I'll split the b squared nicely, evenly. And then my signs need to be a positive and a negative. Now it could be a positive and a negative like this, and maybe that's the way we wrote formulas in earlier videos, or you might see examples where instead they're this way. But a minus b times a plus b, and what you saw a second ago, a plus b times a minus b, they're equivalent. Okay, so let's do an example to help kind of burn this in a little bit. Let's see, so 25x squared minus 4y to the 6th. Before I look at any details of that, always look for a greatest common factor first. Looking at the first term, I see 5s, 25s, x's. In the second term, I see 2s and 4s and y's. So I don't hear anything in common, so that's out. That means that I should look to see if it's a difference of squares. 25, yep, that's 5 squared. X squared, obviously what you get when you square x. 4, that's 2 squared. And it might be a little more subtle, but y to the 6th is actually a perfect square. Even though 6 is not a perfect square, y to the 6th is. We'll demonstrate that at the end as we check it. So 25x squared isn't too bad to split evenly. 5x and 5x will get that job done. That plays the role of a. And now this is how you're going to split the 4y to the 6th. You split the 4 evenly, and then you split the y to the 3rd evenly. And if you think about it, if you were foiling this out, if you were checking, when you multiply these together, you'd be adding your exponents. 3 plus 3 gets you 6. So what you learn is that any even power, any even exponent is going to be a signal that that variable piece at least is a perfect square. Fill in my signs, and I'm done. I factored. Okay. So that's off to the side now. Let's move on to what happens if you have, because that's the entire list for 2 terms. Let's look at what happens if you have 3 terms. Well, if you have 3 terms, largely what you're going to do, once you look for a GCF, is you're gonna answer the question, let me find factor pairs of blank that add to blank. And that's a real general way to describe it, but I think that's a good thing. That means we can basically talk about one technique with an asterisk. So not only do you have the asterisk of like look for a greatest common factor first, but you also have a helping tool. It's not necessary, but it's a helping tool that if you know about perfect square trinomials and you check for perfect square trinomials, you might cut down on your work. We learned that earlier. If you notice it's a perfect square trinomial, then you would have noticed the 3 terms have something special about them. The first one's a perfect square, the last one's a perfect square, and the middle one is just right. It's 2ab. If you notice that, then you can factor it with perfect symmetry, a perfect match. It's a perfect square after all, so a plus b times itself. Or you will see plenty of people write it as a plus b, the quantity squared. Okay. What if it was a minus sign? Well, you have room for some minus signs, but not all. B squared, anything that you square, whether it's positive or negative, would become positive. But this middle term can be a negative. So notice in the last one, if it was a plus, both of those are plus. If it's a minus in the middle, both of those are minus. Let's see an example. So factor this. Okay, well, first, look for greatest common factor. I see three terms, x's and 2's, 2's but no x's in the 60. Okay, no greatest common factor all the way across. So that means I'm hoping that it's going to maybe be something where I could find factors of the last term, negative 60, factor pairs of negative 60, that add to negative 4. And as I hear that, I think factors of negative 60 have opposite signs. And when you add numbers together that have opposite signs, a lot of times it feels a lot more like subtraction. I want to have all that going in the back of my mind. So I will start to factor. I'll write two parentheses, each big enough for two terms. I'll split the x squared evenly. There's no complications of a number in front of the x squared yet. That's good. I'm looking for factor pairs of 60 that add to 4 or negative 4. So 1 and 60 are very far apart. 2 and 30, no. 3 and 20, getting closer. They're still 17 apart. 4 and 15, no. 5 and 12, getting closer. 6 and 10, there's your winner, 6 and 10. So I now have the makings of a 10x from the outside and a 6x from the inside for my outer and inner product. Play my signs right and I'm good. So I'll make a negative 10x and a positive 6x. So that's one way we can apply this. Find factor pairs of blank that add to blank. Set that aside. What's another example that would fit 3 pairs? Well, here's one. And no, that's the number in front of x squared. The number in front of x squared, we have spent over a week on it, and we find it still challenging. But always look for a greatest common factor first. Because if you look at these 3 terms closely and you can remember, always look for a greatest common factor, you'll actually be thrilled to find there's an 8. And because there's an 8, I can write one big set of parentheses big enough for 3 terms. I'll throw the common factor 8 outside and I'll go through term by term and say what's left. X squared from the first term, 1x from the middle term, negative 6 from the third term. So now we're actually not factoring something with a number in front of x squared. We're factoring x squared plus x minus 6. So the question becomes, what's the factor pair of negative 6 that adds the 1? And that's a smaller list. 1 and 6 are not apart by 1. 2 and 3 are. So that's what we're going to go with. We're going to go split the x's, x squared, 2's and 3's, make the signs right. So my outer product plus my inner product can be positive even with different signs. That would mean like that. Okay. So we got that one set aside. Next. Okay, now we got a face facts. We got the number in front of in front of x squared. We've already seen the one where it factored out. We probably can't factor out GCF, but look anyway. 4's 36 has a 4 in it. 81 does not. Okay, all right. Greatest common factor out. Well, let's check for a perfect square trinomial. A reminder, that means the first term has to be a perfect square, which it is. The last term has to be a perfect square, which it is, and we can't be satisfied yet. The middle term has to be a 2 times a times b. It has to scream of symmetry. You have to have a perfect match. 2 times a times b. 2 times 2 is 4, times 9 is 36, 36f. This is good. We don't need to go through all the little gimmicks we've been doing with a number in front of x squared. If we recognize it's a perfect square trinomial, so that means we split the 2f squared perfectly. That's whether you're using this notation or the one that I had kind of mentioned at the outset. Splitting the 81, it would be 9's. And because the middle term is positive, it would be positive 9's. So either way, you could write this thing factors like that, or this thing factors as 2f plus 9 squared. So as we kind of store that for record, we'll use the 2f plus 9 squared. One more with 3 terms. Look for GCF first. Don't see one. Look for perfect square trinomials. 6 is not a perfect square. So now we have to do our work. But we don't have to go any further than this. This is kind of where this system, this plan works. 2 terms, look for difference of squares. 3 terms, know at some point you need to ask yourself, I need to find factor pairs of blank that add to blank. And in these early cases, because by the time we factored, there was no number in front of x squared, we were using factor pairs of -60. We didn't use factor pairs of 48. If you remember, we used factor pairs of -6. In this case, we have that observation that we need, where we think of factor pairs of that product, factor pairs of -18 that add to -17. And actually, that's not going to be too hard to figure out because 18 and 1 is going to let us do a 17. So what you do with that is up to you. You've watched many videos on this now. The most efficient way is to say, I know my outer product needs to be some kind of 18, or my inner product needs to be some kind of 18. I set up the outer product as 18, see what's left. What's left of the 6G is a G. What's left of the 3 is a 1. You play your signs right, and you got that thing factored. And then finally, and I told you this was going to be a long video, so I hope it's just something you can replay when you need to. Four terms, there's one kind of factoring by grouping. So an example would look something like this. Now you still want to always check for greatest common factor first. And while I see a lot of common factors 2 or 3 at a time, not every factor has an X, not every factor has a Y, not every factor has a 2, not every factor has a 3. So there is no greatest common factor all the way across. So we go into grouping. Remember, grouping is looking at 2 sets of 2 terms, rewriting each set of 2 terms by doing a GCF within those 2 terms. So these 2 terms got rewritten this way, because I noticed there was a 2xy. These 2 terms got rewritten this way, and I chose to take out a -3y, because remember, I was really trying hard to make this set of parentheses match that one. That was so I could move on to my second step, which is take out that common factor that I just found, the x plus 5y. That's why it was so important. And then go through term by term and say what's left. That's what's left there. That's what's left there. We're finished factoring that problem. So factor by grouping. So we're 12 minutes into this thing. Again, it's just a nice resource to have. When you go to factor, look for a GCF first, and then commonly think, how many terms do I have here? If it's 2 terms, you're looking for a difference of squares. If it's not a difference of squares, you can't factor it right now, not in Algebra 1 at least. After you take out a GCF, if you're looking at 3-term expression, then at some point you have to say, this is where I need to say, what are the factor pairs of blank that add to blank? And that could sometimes be as simple as looking at the last constant, and sometimes you need to do that observation where you use this outer product and you use it as you see fit. Still going to be a goal of us to get better at that as you work your way through your next couple math classes. So don't feel terrible if you're not an expert at that yet. But I hope factoring by grouping is coming along. When you have 4 terms, that's what you do. Take out a GCF, look to group them 2 at a time, and take it from there. So this is the last day that you're going to hear me teaching factoring. From now on, we're going to use factoring. Maybe we'll use it to do multi-step factoring. Maybe we'll use it to start solving equations and solve problems. But when I talk through those things quickly and I don't really slow down and teach factoring, it's because I know you've got plenty of resources, plenty of videos to go back and look at to sharpen up your factoring that you feel like you still need some time on. Thanks.